Hi guys. All right, so here we go. First ever video lesson. I hope you're excited. Let's see how this goes.
Excited.
I'll try my best, and you try your best as well. All right, so this next unit, unfortunately, this is like brand spanking new. It's a little abstract. So I'll do the best I can to help you with it, and you do the best you can as well. And feel free, you always can go on Delta Math, and you can look up some of these topics, and there'll be videos there, YouTube videos. You don't have to just use the video that I'm giving you. But this video obviously will correspond to the notes packet that I gave you. Okay, so let's get started. So the first day here, though, is going to be nice and easy, and it is just a review of piecewise functions and rationalizing. So that's what we'll work on today, so not so bad. All right, so piecewise functions. Remember, piecewise function is where we have different components of the function with their own domain. So we're going to take each one. We'll go off to the side. And we'll make a little table of values. And remember, there's no calculator for this. Okay, so the domain for 2x plus 3 is x is less than or equal to 1. So that means I'm going to use 1. I know that's going to be included, so it's going to be a closed circle. And then numbers that are less than 1. And you could just do a few. We don't need to do a lot. And then we'll just plug each one in. So if we plug in 1, 1 times 2 is 2, plus 3 is 5. If we plug in 0, we'll get 3. And if we plug in negative 1, we'll get 1. Okay, let's do the same thing for our second piece. So negative x plus 4. The domain for this one is x is greater than 1. So we'll have 1 with an open circle, and just do a few. So now if I plug in the number 1 into this function, I'll wind up with 3. If I plug in 2, I'll get 2. And if I plug in 3, I'll get 1. And remember, let me just make more room here. Okay, so at this end, the function is going to continue. So I'm just going to put an arrow. Maybe the arrow is going up, down, sideways, I don't know. And the same thing on this guy. We could do more numbers, so I'll just put an arrow. And we'll figure out where the arrow goes when we start graphing. All right, so let's graph the 2x plus 3 function. Okay, let's see how this goes with graphing here. So negative 1, 1. Oh, goodness. 0, 3. This is fun. And 1, 5. Okay, so we started at 1, 5, and we could keep going this way, more negative. So we'll just make a line. Now let's graph the other one. So 1, 3. So 1, 3, we kind of open circle, which we can see that makes it still a function because it passes the vertical line test. We have 2, 2. We have 3, 1, and then we know that it still continues on going this way. I'll do the best I can here. And there we go. So we graphed a piecewise function. Okay, a little review there. Okay, moving on. What if I want you to evaluate a piecewise function? You just have to find the correct domain to put it into. So if I want to find k of 5, which domain does k of 5 fall into? So the domain for the first one is x is less than or equal to negative 1. Next one is x is greater than negative 1, less than or equal to 1. But here it is right here, right? 5 would fall in the domain of x is greater than 1. So we'll throw that in. 1 minus 5 squared. So k of 5 is equal to negative 24. All right, next piece, k of negative 3. Again, we just have to find the domain. So, which domain does this fall into? So it falls into this one right here. X is less than or equal to negative 1. So k of negative, oopsie. Okay, k of negative 3 is going to be equal to 2 times negative 3 plus 1. So k of negative 3 is equal to negative 5. Okay, so just practice review of evaluating a piecewise function. You just figure out which piece of the domain that it falls into. All right, so now we're going to get into some stuff that I don't know if we never really spoke about it, but it definitely will make sense. All right, so we want to graph f of x equals the absolute value of x. So we should all be very familiar with this. We'll make a little table of values over here, although I think I'm not giving you a domain, so it is all reals. I'll start out with negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. We could keep going forever. When I plug in the absolute value, the result is always positive. It's just a distance from 0. So the absolute value of negative 3 is 3, 2, 1, 0, 1, 2, 3. We all know that already. And go ahead and graph it. And I think we remember that it looks like a V. Ooh, okay. And there we go. But we can take an absolute value function and we can separate it into a piecewise function by doing this. Let's focus just on this piece right here. If we focus on that and we wanted to write the equation of that line, the equation of that line is y equals x. Oh gosh, let me get the y equals x. So I can go over here, and my first piece is y equals x. I have to state the domain. Well, one of the pieces has to include this value, so I'm going to let this one include it. So x is greater than or equal to, what is the domain if I go in this direction? X is greater than or equal to 0. So this piece here represents this part of the function. Okay, now let's do the other part of the function. What is the equation of this line? The equation of that line is negative x. And x is less than 0. If I were to look at the domain, right, I'm going this direction now. So this, oh, didn't mean to do that. And then I don't think there's an undo button. Oh, there is. There we go. So this piece right here represents the red line. And it's just an equation of a line. So now we know, let me get a pen. Oh. Okay, now we know there's another equation that gives the same graph. And it's that piecewise function right there. So this guy right here is exactly the same as f of x equals absolute value of x. Okay, so this is super important that we try to understand and try to memorize. All right, so if that's the case,